In a parallelogram ABCD, E and F are the midpoints of AB and CD. So these are midpoints. Respectively, show that the line segment AF and EC trisect the diagonal BD. So first thing is, what is trisection mean? Trisection means that we have to prove DP is equal to PQ is equal to QP. Okay, trisection means three equal parts. So let's begin with what is given. We have ABCD is a parallelogram. So what does a parallelogram mean? They have equal and opposite sides. Okay, to begin with. Then opposite angles are equal. And the third thing is about diagonal. So always remember in this way: side, angle and diagonal. So make a habit of this. So whatever diagonals, the diagonals bisect each other. Okay, so those are your property of parallelogram. And we have E and F are midpoints of AB and CD respectively. So we are looking at what is that we need to prove. To prove AF and EC trisect the diagonal BD. That is, we have to prove that PQ is equal to QP is equal to PD. Okay, so we need to prove that these three lengths are equal. Now, how will we go about doing this? Okay, I'll give you guys the first clue. One thing is, we need to make use of midpoint theorem. For that, we need triangles. So I'll give you guys first clue. So this is the triangle. So what is the midpoint theorem talking about? For that, what is the condition that we need? And we already have F is the midpoint of DC. So how can we make use of this? So these are all the things that you need to figure out. Okay, so let's talk about midpoint theorem. Converse of midpoint theorem talks about if I have a line, right, parallel to the third side and crossing one of the side as a midpoint, the other side will also be the midpoint of the second side over here. So basically I have to prove that FA is parallel to CE. How will I prove this? Things are parallel. Well, we have been given ABCD is a parallelogram. Can we make use of that? Well, we can and we should. So we have the proof. So let's begin with consider parallelogram ABCD. So AB is equal to DC, opposite side, right? And AB is parallel to DC. Okay. So let's call this as 2x. Let AB, which is equal to DC, let this be equal to 2x. So this entire length is 2x. Now, with all of this in mind, let's talk about FC, which is equal to DC by 2. So this will be equal to x, as F is midpoint. Okay. So we have on a similar line AE, which is equal to AB by 2, which is equal to x. Here E is midpoint. Okay, so what does this help? Well, if I show you guys, I hope you guys are able to realize this. FC is parallel to AE. This is X, this is X. So what can you conclude? Yes. So we can conclude that in AFCE, AFCE as FC is equal to AE is equal to X, and FC is parallel to AE, right? So quite a few things we have discussed already. This implies AFCE is a parallelogram. Okay, right? Very simple. So this is a parallelogram, and so we have this set of lines to be parallel to each other, right? So let's look at it again. This is okay. FC is parallel to AE. We'll write it from 1, right? Just for the case of, if your teacher, they tell, no, where do you get this from, we can point out from 1. Okay, so this is just from the previous written steps, so that's okay, right? So we proved that this is a parallelogram. This implies AF is parallel to EC, opposite sides, and yes, everything else is by default implied. PF is parallel to QC. Now we are good to go. So we are pretty much done writing all the required things. Now talk about, consider triangle AQ, no, DQC. Oh, I've been writing it as AQC. I'm going to write it as AQC, but it's DQC. As F is a midpoint and PF is parallel to QC. Okay, we need to write that as F is midpoint and PF is parallel to QC. This implies P is midpoint of DQ. Okay, right? Then, so we can tell D, therefore DQ is equal to DQ DP, which is equal to PQ, right? Therefore these two are equal. Reason being this we'll be using. So we'll tell similarly in triangle I think APB as EQ is parallel to AP. Okay, so we are talking about this triangle, by the way. Sorry, I didn't show you guys that. So let me show it off. This is a better color for now. This one. Okay, so here we have E is a midpoint, so Q will be the midpoint, and this is parallel to this, right? So EQ is parallel to AP. Okay, and E is the midpoint of AB. This implies Q is midpoint of PB. Okay, so yeah, I forgot to write the reason. Converse of midpoint theorem. Converse of midpoint theorem. Okay, so because of this we are able to conclude, and so we can here conclude that PQ is equal to QB. So from all of this, what can we tell? dp is equal to pq, pq is equal to qb. So from equation A and B, we can talk about, from A and B, we can tell dp is equal to pq is equal to qb. Hence, db is trisected by p comma q. That's it. Okay. So that's all you had to prove. db, yes. So this is the one which we have to prove indirectly, and we did that. Actually, at p and q. Okay. So this is your answer.